Good afternoon, everyone. My name is Crystal Stabell, and I am with the United States Energy Association, working with the National Energy Technology Laboratory on this joint webinar on the Carbon Storage Planning Inquiry Tool webinar. So a little bit about the USEA. The United States Energy Association is a nonprofit, apolitical, non-lobbying organization founded in 1924. USEA's mission has two pillars of equal importance. USDA serves as a resource by convening energy stakeholders to share policy, scientific, and technological information to foster the advancement of the entire energy sector. Internationally, USDA promotes energy development by expanding access to safe, affordable, sustainable, and environmentally acceptable energy in partnership with the US government. To give you a little bit of background on what's going to be going on today, first, for housekeeping, this is going to be a recorded webinar, and we will be having a Q&A at the end. So if you have any questions that you would like to ask throughout the webinar, I ask that you please put it in the Q&A box down here, and I can get to them towards the end. We'll first be beginning with an introduction by Paige Morkner, a geologist at NETL. She will be going through her presentation. After 40 minutes, we'll be having a Q&A session followed by closing remarks. So Paige, if you would like to go ahead, we can get started on the discussion.
Thank you, Crystal. Okay, sharing my screen. All right, are we good to go on the screen share?
Yes.
Okay, great. All right, good afternoon, everyone. So I'm Paige Morkner, and I'm a geologist and geodata scientist at the National Energy Technology Laboratory, or NETL. NETL is one of the Department of Energy's national labs, supporting a variety of research portfolios within the Office of Fossil Energy and Carbon Management, or FECM. Today, I'll be speaking about one of the tools NETL has developed under the Bipartisan Infrastructure Law, funding to enable data discovery to support carbon capture, transport, and storage feasibility analysis and planning across the USA. The Carbon Storage Planning Inquiry Tool, or CS PlanIT, or PlanIT, as I'll be calling it throughout this talk. I just want to take a moment to thank the USEA for the opportunity to present today and for hosting this webinar. This is a necessary disclaimer that I am required to show for all public presentations. And I want to take a moment to acknowledge the team of individuals who have worked together to develop the PlanIT tool. So before I dive into the tool itself, I want to take a step back and mention that there have been a number of efforts across DOE to support carbon capture, transport, and storage for 20 plus years now. These efforts have included the funding of the regional carbon sequestration partnerships and initiatives, the development of the NatCarb database, or the National Carbon Sequestration Database, and Atlas, and the funding of the Carbon Safe Field projects, as well as a number of other efforts. In 2011, NETL, with the support of the Office of Fossil Energy and Carbon Management, developed the Energy Data Exchange, or EDX, as a central repository and digital laboratory to support the curation, preservation, and dissemination of public DOE FECM products. And in 2015, the DOE Carbon Storage Program set in place the requirement for DOE-funded carbon storage data products to be published to EDX. As a result, thousands of data resources representing millions of dollars of investments have been preserved and published on EDX, spanning field-specific data sets for regional and basin scale, field-specific data sets, as well as regional and basin scale data sets and studies. The ability to collect, store, and share data from the DOE Carbon Storage Program promotes reuse for those products to further future research efforts and project implementation. We've seen reuse of data from EDX and the Carbon Storage Program for a number of different purposes, including feasibility analysis, risk assessment analysis, geomodel development, tool development, and permit development for CO2 storage. When the bipartisan infrastructure law passed in 2021, funding became available to build additional digital infrastructure to support carbon storage efforts. As a result, NETL has developed a number of tools, datasets, and resources to support stakeholders with their own planning, feasibility analysis, optimization, and data discovery processes. Any of the things that I've mentioned on the slide here are all available on EDX. A lot of these data sets that are mentioned and other items that are located here. And that link is at the bottom of the slide here. So planning for carbon capture and storage projects is typically data intensive, requiring the assessment of hundreds of parameters from geologic data to infrastructure to source to sink analysis, regulatory understanding, hazard analysis, as well as environmental justice and social justice, and even more. With the number of public data sets that have been produced in relation to all of those different factors, it was identified that synthesizing these data sets into a user-friendly dashboard would be beneficial to stakeholders who would want to access them for their own purposes. Access to data is critical to enable assessment of geologic feasibility, but also community and environmental factors along the whole CCS supply chain, from capture to transport to storage. And that's a big reason why we developed the Carbon Storage Planning Inquiry Tool, or PlanIT, which was developed in response to that identified need. PlanIT seeks to support the development and deployment of large-scale CCS through informed planning. So PlanIT is a dashboard that integrates thousands of individual attributes across multi-source data to enable users to assess CO2 emission sources, natural hazards, prospective storage resource information, environmental justice and social justice, and critical energy infrastructure. PlanIT was designed for a wide stakeholder community with the intention of it being usable to anyone who wanted to understand what data is available for their area of interest. We designed it with a number of questions a potential user could have in mind, such as what is the candidate infrastructure available for reuse? What are some of the CO2 emission sources, and what are the amounts of CO2 they produce that would be available for capture, and many more. We released the first version of PlanIT a few months ago and are continuing to update the dashboard to enhance functionality and add additional relevant data resources. We expect to have additional updates to the tool in March of 2025. In the initial phase of the development of PlanIT, over 40 datasets were identified for integration. As a result, a data catalog was published alongside the tool to enable users to quickly review what data is available within the tool and access that data from its original source for their own needs and purposes. So even though we've integrated that data into PlanIT itself, we also like to have data and metadata transparency for our end users. So by developing that data catalog, it's available as a separate product or a separate resource for users who may be more interested in just the data itself, collecting that data, going out to the original source, downloading it, etc., integrating into their own analyses. The different data sets that are included within PlanIT align to essentially 5 distinct categories of information, which are the basis for the organization of the different widgets and functionality of the tool. In more detail, these different data sets include carbon dioxide emission sources, which include emitters ranging from industrial manufacturing, electricity generation, refineries, cement production, steel production, and more. These are all sourced from the Environmental Protection Agency, or EPA's flight database. There's data about energy infrastructure, including CO2 and oil and gas pipelines, wells, ports, waterways, all sourced from various state and federal agencies. There's CO2 sinks and CCS projects. So these include currently submitted and permitted Class 6 locations and past carbon capture and storage projects located or locations sourced from the EPA as well as from the DOE and from Class 6 primacy states. And we have prospective storage resource estimates for saline, depleted oil and gas, and unminable coal seams sourced from the National Carbon Sequestration Database, or NatCARB. There's information about natural hazards, including faults, fractures, and geologic structure data sourced from the U.S. Geologic Survey, as well as groundwater aquifer information sourced from the U.S. Geologic Survey. And then we have 3 indexes for environmental justice and social justice data, including the Climate and Economic Justice Screening Tool, or CJEST, the Center for Disease Control, or CDC, Environmental Justice Index, and the CDC Social Vulnerability Index. There's also information integrated into the tool about population and different kinds of land classifications, such as federal land and tribal land, and other types of land classifications. And some key features of PlanIT include the ability to query and filter data based on location, charts and maps that act dynamically based off of search queries, maps and legends for exploration of data resources, and external links, as well as metadata documentation for all data displayed, which is key to ensuring transparency for the user around what data they're viewing and interacting with. And with that, I am going to switch over to a live demo. The link that I'll be showing will be the one that is in this window here, and there's a QR code for folks who are interested in viewing or following along. And I'm going to go quickly switch over my screen. Within the EDX submission, we'll be taken to the application itself. That will open up in a separate window that will be loading up like this. You'll see your standard disclaimer, description, and a support email that you'd be reaching out to if you have any issues. This is the correct place to contact and support. And then we agree to the terms and acknowledgements. Within PlanIT itself, there are a number of capabilities, widgets, etc. At the center of PlanIT is the map itself. Up in the top left corner, we have a layer list that allows you to actually click through and look at all the different data that's included in here. You can turn on and off layers as needed. There is a base map gallery, so if you want to change the look and feel of MapIt itself, so the underlying map that the data will be displayed on, you have that option. We also have a capability of bookmarking or saving locations that you query within the tool. So say you want to explore a number of different locations at the same time, you can save those and come back to them. We have a print function, so you'll be able to do that, print maps, etc. from PlanIT. And then there's also an add data capability. So if you have data on ArcGIS Online or on Arc Enterprise, you can add that in from your own data stores. You can look for URLs for other data services or web services or REST services. And then you can also upload files to PlanIT in order to add them to the map. Just kind of moving around in a counterclockwise fashion, I'm just going to quickly review. I already went over what data types are included within PlanIT, but just to quickly review like how this works, what's in here. We have CO2 emission sources by industry measured in tons. You can hover over these things and see what are the different industries that are included in here. There's also the ability to do an industry filter, so you can actually look for plants based off of the specific interest. And then all of these widgets have this About tab, which contains information about the data sources that are being shown. So you'll get a description for each one, as well as the link directly to the original source. So that About tab exists within each of these widgets and makes it really easy to understand, what am I looking at? Where is it coming from? How can I access it? We have well infrastructure and well counts. That's what's going to be in this window here. This is our prospective storage capacity estimates for saline, oil and gas, and unminable coal, coming in from the NatCarb database. We also have saline, oil and gas, and coal formations. So when you query a location, it'll actually give you information about the specific reservoirs or prospective storage reservoirs for CO2 storage within your area of interest. We'll have the National Risk Index, geologic structure, as well as aquifer information. Then all of those EJSJ indexes, as well as the social vulnerability index. And up here we have population, CO2 projects, CO2 pipelines, oil and gas well tracks, and then facilities. And all of these are dynamic. So I think what I'm going to just do is add a location to our map. Let's create a search radius of 100 miles. And we're just going to select and set a location. And PlanIT will react by basically customizing all of the information within the dashboard based off of your location of interest. So you can see all of the data sets are loading into PlanIT, and you're getting a lot of that information then shown on the map. Here's your radius to the location that I selected. You can either select a location on the map, or you can type in your address within the map. You can then go through and actually explore the different data sets that were queried for your area of interest. So you can see these boxes appearing around our different sources based off of what I click on and select. Same goes for all of these. So say we're interested in where are my federal lands within my area of interest. Those are going to be these areas in red. And so you can view kind of one at a time each of these different things. So let's zoom out again a little bit. We then can also look at the different widgets and see those dynamically change on your map. So you're going to have things like CO2 emission sources. Where are my electricity generation plants? Well, now those are going to be bounded by those blue boxes on my map, etc. For these different industries as well. We also have well counts by status. So these are organized by tracts, or so they're aggregated from proprietary data into a more generalized map. We are currently working on integrating another resource from NETL called the CO2 locate dataset into this tool, so that folks can see well locations and well header information. So more well information to come. We have CO2 storage estimates. So these are showing up as our grid cells within our map. So we can see like where are the low estimates for saline storage in this area, medium, and then high based off of NatCarb. And then what are those storage reservoir units, those prospective storage reservoir units, such as the Mount Simon, the Knox Group, or the St. Peter Sandstone. We then can also look at the aquifers in this area. So just kind of walking through and looking at the different data resources. These things will get highlighted on your map as you kind of click through the widgets and look at the information and data within PlanIT. And then same goes for the disadvantaged communities. We have the ability to kind of highlight those on the map, see where they're located, etc. Population changes, so that's going to be based off of my radius here. You can see we have 8 planned CO2 injection projects. So these are actually where Class 6 permits have been submitted within this area. We have over 1,000 oil and gas wells, and then you can see some of the pipeline information as well, is some of these blue lines running through here. And then we have 192 facilities. So that's kind of how PlanIT works. Going to just quickly switch back over to my PowerPoint slides. So let's see. So to wrap up this talk, I just want to mention again that PlanIT is only one of many tools and data sets that NETL has developed as a result of the development of digital infrastructure to support carbon capture, transport, and storage as part of the bipartisan infrastructure funding. There's a large number of other products that are available, and this is just a overview of a lot of our public products. So PlanIT serves a very broad purpose. It is designed with the idea in mind of supporting planning of CCS and all the not all the underlying, but many of the underlying factors that one would want to take into consideration when taking on project implementation and location selection for CCS. But we do have a number of other tools and data sets that have been produced within DOE and NETL that support carbon capture and storage in different ways. So just kind of walking through these real quickly, we have Rockbase, which is a core repository exploration tool. We have the Connect platform, which enables access to DOE CCS projects for specific information and location. So wanting to understand where all the DOE projects are and what's being done. We have the offshore geologic carbon storage inventory web application. This is an application based on information publicly collected internationally for offshore so that folks can understand what data is being collected and where those projects are being implemented. We have the prospective seal name catalog, which is a data set that aggregates data for prospective seal units for carbon capture and storage within major basins in the US. We have the CO2 locate database and web application, which is a massive public data collection effort to pull and aggregate public wellheader information into a uniform database and central location from different state entities. We have the carbon storage site mapping inquiry tool, or MAPIT, which is a complement to PlanIT, but MAPIT is tailored directly to the Class 6 process, and the data that it curates is very specifically tailored to the documentation that was released by EPA that describes the data and the requirements for a Class 6 permit, and aggregating and making that data into a dynamic tool that allows access, not dissimilar from PlanIT, but with a very specific, very specific goal in mind. We have Giza, which is a geospatial anonymization tool. We have AIM, which is a pipeline integrity model for understanding, the lifespan of pipelines, both onshore and offshore. We have a basin scale structural features database, which really focuses on understanding structural complexity at the basin scale for basin scale geologic storage analysis. There's the CCS pipeline routing planning tool and database, which are the Smart CO2 Transport Route Planning tool and its complementary database, which is a tool that takes into consideration a number of different factors for transport planning for CO2, including pipelines, but also other transportation routes, and then taking in things like environmental justice and social justice data in the process. There's the Technical Viability Assessment database, which aggregates a number of data sets together into comprised of thousands of data layers, and then assesses them in the framework of technical viability for CCS. So where's the data, and what are we missing? Where are the big gaps in the data that we need in order to fully understand, CCS potential in the US and assess a location for it? And then we have the CCS EJSJ database, which is a database that's focused on environmental justice and social justice from the framework of carbon capture and storage. All of these are available on EDX, but also on our carbon capture, transport, and storage hub called Discover, which has the link here at the bottom as well. So Discover is a CCS-specific data hub, tool hub for the CCS community that helps filter and enable communities to interact with data that's on EDX that's specific to the CCS community, or CC, carbon capture, transport, and storage community. And with that, I think I will wrap up, and I just want to take a moment again to thank everybody for being here and for the opportunity to speak, and an apology for the technical difficulties. These things happen. And of course, if you're interested in anything mentioned today, please don't hesitate to reach out. I'm happy to provide links, etc., to anything mentioned, planet related or beyond. And yeah, thank you.
Well, let's see. Thank you very much for your presentation. And now, if anyone has any questions, we are happy to take them. We have one question here. Could you explain once again how you got the black pane with list of data activated on the left side? Not the data layer, the other list on the very left side. Would you be able to pull up the web page?
Yeah. Okay, let's see. I think I stopped sharing my screen. Hold on. Sorry, can you repeat the question one more time?
Yes, in the chat here. Could you explain once again how you got the black pane with list of data activated on the left side?
Yeah, so yeah, this is just based off of the query that I typed in. So
could you share your screen, please?
Oh, yeah, I thought I had shared it. Sorry. Okay. It should be coming up here.
I see it on my end, so Crystal, you might be looking at your presentation.
All right.
Okay, perfect. So this query over on the left side, when you don't have anything in there, it will be blank. But once you type in an address or you drop a pin, so you can kind of set your results distance to whatever you'd like here, and then you can either drop a pin on your map, or you can type in a location, and you will get it populating with all the data within your search radius. So here we'll drop a pin. Hold on. Set location. And then it will populate with all the data that falls into that search radius. And it is thinking very hard about all the data that it is currently trying to pull up for me. But yes, this will populate with everything that kind of falls into your search radius.
And Paige, as a follow-up to that question, does it work a little bit faster if you have kind of a smaller search radius, or
Yeah.
the opposite?
Yeah. So optimizing kind of as research criteria can be a little bit finicky, but yeah, it definitely it can be a little bit more quick depending on your smaller search radius, because it's going to be querying a lot less data in that process. Yep.
Okay, thank you.
Well, does anyone else have any other questions? Yes, Mark. Would you like to type it in the chat, please? We've unmuted you if you also wish to ask it in person.
Yes, can you hear me now?
Yes, we can.
Oh, yeah, okay, cool. Will there be a link or something sent to get to these pages? Because I'm finally getting in, but I'm still not finding CS Planet. I had to go in the public way, and I'm still not seeing CS Planet. I'm with the Forest Service Department of Agriculture, and I'm not seeing that. So hopefully after this meeting, there'll be something that'll say how to get there directly.
Yes, we will be giving access to everyone to the tool through our website. The presentation will be available as well as will the recording of everything today.
Outstanding.
Great. Thanks, Mark.
Now, is there anything else we can answer? Well, if nobody else has any other questions, before we go, I would first like to let everyone know that we have many events going on at USCA, and the next one that we're going to be offering is going to be taking place tomorrow. It's going to be our final webinar in the National Tribal Energy Roundtable series that's going to be focusing on the Trail of the Chiefs Energy Corridor. So if you're able to attend, we would love to have you, and you can find more information on our website. But with that, I would like to thank everyone for attending, and thank you very much, Paige, for taking the time to speak to us. And with that, I will go ahead and close things out. Thank you very much, everyone, and have a good day.